Good afternoon and welcome back to the workbench. Welcome back to this Dixmouth power supply, the Q-1760, or well, again, it's by Manson Engineering, or Manson Industrial Engineering, I think their name is. Not sure what the original model is, but anyway, it's a Dixmouth Q-1760. It has a problem, or it had a problem. As you saw in the last video, the voltage control potentiometer was bad, has a bad spot down the bottom end, so if you're trying to adjust this thing to a low voltage around like 1-2 volts or something, it'll suddenly spike up to 15 or maybe even higher, which is not good. So obviously I needed to replace that, and I ordered some new potentiometers from AliExpress, and I've got 5 of them here. I've also got some new capacitors from Farnell to replace the ones in here because I don't trust the quality, and I've got a new fan which I will probably put in too. Now there are some annoyances here, I'll just get to that. Maybe I'll put this up here. So these potentiometers that I bought, as you may be able to tell, the keen-eyed among you can see that the shaft type on these is not the same as the shaft type on this. Maybe if I took one out of the bag it would be more obvious. So yes, while they are physically basically the same size, and they will fit in the PCB and everything's good there, that's not the problem. The problem is that the shaft type is not the same. This is a flat sort of D-shaped shaft, and this is a spline shaft. So, yeah, that's not what I ordered. Well, it's not what I thought I ordered anyway. But as you can see on the website here, these are the ones I ordered, and the picture shows clearly a spline shaft there. And if we scroll down, the description. There's nothing here saying that it has a different shaft, and you can see the full picture here. It definitely shows a splined shaft very clearly. There are no other pictures showing any other type, and yeah, there's nothing there in the description at all. It just describes the different values you can buy and just has like generic sort of things, but yeah, there's nothing saying that these are actually flat shaft ones at all. So yeah, that's kind of annoying, so I'll be requesting a refund for those because that's not what I actually ordered. However, they're still usable, I suppose. Obviously I can't use the original knob on it because this is designed for spline shafts and won't work on this one, but I do have another knob here off an old television which has the D-type shaft type, so this will actually fit on there, and it does fit on the front panel, and it's long enough, so this should be usable for this potentiometer. It obviously doesn't look the same as the original, but it will work. And then I suppose what I'll do is I'll eventually order the correct one from Mouser and replace it anyway, because again, we don't really know the quality of these. This is some cheap generic thing from AliExpress, and I wouldn't have a clue how long it's going to last, because this one didn't seem to last very well either. But yeah, and like I said, I'm going to replace the capacitors. They look fine, there's nothing bulging on here. These ones all look okay, but they are Capexon brand, and those aren't known to be the best ones. Even though these are, in a very sort of low temperature use, sort of basic thing, they're not going to fail necessarily very quickly, but I still don't think they're very good quality. It's usually in switch mode power supplies that these things really fail pretty quickly. These aren't low ESR ones, of course, these are just general purpose ones, but that's a good question because if we go back to the internet over here, for example, here's there's some posts about these supplies on the EVBog forum. This one, oh yeah, it's interesting here, I noticed this one, you see this has got this little yellow Dixmouth logo that's a square, and that's kind of the logo that Dixmouth had right in the later years before it closed down. So it's interesting that my one doesn't have that. As you can tell, it doesn't have that there. There should be a Dixmouth badge up here, but it's fallen off, I suppose. But yeah, it shows that my one is probably older than this. The date codes were confusing on it. I haven't found anything that really is certain of how old it is, but it's probably older than maybe I thought, because this style would have been one of the later versions. But yeah, we got another post here which I thought was interesting because I just noticed this is one someone picked up in pieces and wanted to fix it up, and it's quite fascinating because you can see down here someone has replaced the potentiometer with a new one and mounted it to the PCB directly. So yeah, it looks like that voltage control pot is definitely a common failure item, it would seem, and if you scroll down further you even see where they've got a picture of the output capacitor, and that's bulging as well. So yeah, it's definitely I think worth replacing those anyway while I'm in here. I don't think there's any point in keeping them. We know they're a cheap brand, and you know other people have had failures with it, so yeah. But that's interesting. I didn't notice this thread we had the potentiometer was already replaced. So that's quite fascinating. I think that goes to show that these aren't particularly reliable. Oh yeah, and another thing that I also found was this website here, CTS Corporation, and they do sell potentiometers, and some of them do look quite similar to the ones in here. So I think this might be the OEM for the pots out of this one. Although if you look through the catalog, there's like standard catalog. There's nothing here that's that looks like the ones that I've got, so yeah, they don't seem to be yeah, we've got all these, but yeah, some of these look similar, like there's a 9mm one, 11, 12, they look similar, but none of these are exactly the same as the ones that are in this power supply, so yeah, it's interesting, but I suppose that's probably where this one came from. So yeah, these probably must be a custom design for Manson, I guess, because they're not a standard product on the website. So yeah, the best you can get are these ones, which are the same size, but they're just round. But yeah, I mean that doesn't really matter. It's not going to make any difference. It will still work just as well or just as badly. Excuse the strange camera angle here, but it's the only way I could fit everything in shot and everything. So we've got these three fans here. This is the old one from the really old power supply. It's about 30 years old, or however much. This is the one in this one, which is probably about 15, 20 years old, and then we've got a brand new one here, which is, well, brand new. Different brand, Orion fans. I could buy these original Sunon ones as well, but this was cheaper and it's the same airflow and everything, so why not? I found it quite interesting though that the diameter of the motor hub is actually larger on the really old fan, and it's kind of medium sized on that one, and then it's even smaller on this one. So yeah, makes kind of sense, I guess. The older ones are probably more inefficient and had to be bigger, and the modern ones are smaller. And yeah, what is nice about these is they still actually work. I thought this one was going to be bad, this really old one, but it still works fine. But you can hear that it's not a great sound, so I'll just hook this up. So, you know, if I switch this on, okay. I thought I was going to switch it on, but apparently it's not doing anything. Is there something wrong with my switch? No? Okay, that's strange. Maybe that one just died while it was sitting on the side. Let's try this one then. I don't know what's happening there. Unless my test leads just randomly died, but I don't think so. Let's try this one. Yeah, that works. I don't know if you can hear the sound. Yeah, that one doesn't sound too bad, to be honest. This one definitely sounded worse. But this one doesn't appear to work now, so it's probably a good thing I bought new ones anyway. Because, yeah, I thought this one was working. But apparently not. Yeah, so yeah, it's not even starting, it's not drawing any current, it's not doing anything, so good thing I bought new fans, because this one appears to be completely dead now. I did test it when it was working, but it was just, you know, it just sounded worn and old, but it was actually spinning just fine. So that's strange. So this is a brand new one. It just has a kind of standard fan whooshing sound. But yeah, I guess I'll probably replace it with one of these anyway. But at the very least I need to take these rivets out and swap it around so it's around the other way. I don't really like the way they've done that, and I've read that it's not particularly good. So yeah, sorry for the shaky camera, but anyway I could get up close enough. But yeah, this rivet style is not one that I've seen before. It's not a pop rivet, there's no like ball thing in it that gets pulled out, but it's got this kind of 4 things that fold over. I don't know how this would be actually put on in the factory. So yeah, the cooling on these things is not particularly great. You've got this fan here which is blowing air in when the heat sinks get to a certain temperature, and you've got the heat sinks here with the transistors on them, and you've got some holes in the case above them, so obviously convection, temperature convection air is going to come up this way naturally, which is fine I guess, and then you've got the fan blowing in, but the problem is it's basically all the airflow is blocked by the transformer, so this can't blow directly on the heat sinks as you'd probably want it to be doing in a sensible design, so it's a bit weird. Yeah, I've read that reversing the flow of the fan and having it sucking out actually provides better cooling to the heat sinks than if you do it the other way. So yeah, I'm going to do that. I'm going to reverse the fan, and I might replace it with one of these other ones or just use the same one. I'm not sure. I don't know how easy it will be to take those rivets off. I might try to get at it with a pair of pliers. Yeah, you can kind of just lever these up with a pair of pliers, but you can definitely grab these little flanges on the rivets and just bend them up with a pair of pliers. So that would be one way of doing it. I might try that instead of drilling them out, because that should create less mess. Assuming I can get the pliers in to get them anyway. Well, that went absolutely nothing like I had intended. I got the fan and the thing off and everything's okay, but I did have to drill these out anyway. Yeah, just bending the tabs off doesn't work. They're too big and wide to fit through the hole, so I found what was actually better was to take some like pointy pliers like this, and I can't really demonstrate, but I've already taken it off, but you've got the 4 little flanges sticking out, and sort of put the pliers in between the flanges and hold it in place so it can't spin round, and then drill it out with a 3.5mm drill bit, and that seems to work, and then you can kind of break them off and pull them out. So yeah, actually more annoying to remove than the pop rivets from the other one, but definitely doable, just yeah, just a bit annoying. So yeah, I've got that out. I've got the grill here, at least this one's not rusty like the other one, and yeah, I've got the fan out, so I don't know, either way, whether I reuse this fan and just switch it around the other way, or if I put the other one in, haven't decided yet. Kind of makes sense to use this one, I guess, because this one still works quite well, and the sound is actually not that bad. It was the other one that had the worst sound. This one actually sounds quite okay now that I retest it. So yeah, I might just use this one, and the good thing is that now that I've taken the rivets out and everything, I can replace the mounting everything with just standard screws, so I won't have the problem of having to do anything like this to get it back out again. So I can put this one in. I might just put this one back in, just facing the other way, put it on with screws, and then if it fails or becomes noisy later on, I can replace it with a brand new one, and that'll be very easy, because all I have to do is just undo 4 screws, unsolder 2 wires, and then I'll be done. So much better option than having to worry about the rivets and stuff. Definitely don't use the rivets to put a new one on, because that would be insane. Alright, so it's time to put some new capacitors in this thing. And a new potentiometer, but let's do the capacitors first. So we've got these 3 here, a 470 25, a 220 25, and a 470 35. Now these are all Capexon GS general purpose series, 85 degree rated, nothing special, and again kind of cheaper brand, and we have seen other people with this power supply where this cap is bulging and not very good, so I want to replace them just as a preventative maintenance basically while I've got the thing apart. Makes sense. For the output capacitor I was able to get this one, which is a YXF, and that would probably be a good series for the whole thing, to be honest, but I only could get it for this one, which fortunately is kind of the most critical one, or somewhat critical. So yeah, I had a discussion online about these, and the idea was that YXF would be probably good for doing the whole thing, because they're a long life rated cap, but they're also not ultra low ESR or anything, and of course this is a linear power supply, so it doesn't need low ESR, but you know, this is part of the output and it could affect the feedback stability or something potentially if it was like a really low ESR cap. I don't know, I'm not actually sure, but it's not necessary to have one. So yeah, but YXF is not super low ESR, it's just a little bit on the low side and has a good lifetime. So yeah, considering this is the one that I've seen blown on the forum there, this seems like the one you want to replace with a good quality one in the first place. And the other two, I've just got Panasonic M series, which is just a general purpose series, like these as well, but these should be better quality, and also they're newer anyway, they're brand new. So unfortunately YXF is discontinued, I think, which is why I couldn't get all of them YXF. These two here are just filter caps for the two voltage rails, plus minus, whatever they are. Here, yeah, if we go here to the schematic, so we've got this this auxiliary winding that powers the control board, and that has a bridge rectifier and a plus minus voltage rail here. You've got a 470 on the positive and a 220 on the negative, and I mean all that's doing is just powering this op amp basically, and pretty much nothing else. You know, there's the relay, I guess. It turns the relay on when it wants to switch the taps of the transformer, but I mean it doesn't provide much current, and a bit of base current to this tip 31. The fan itself runs off the main supply rail, so that's fine. So yeah, I mean these aren't going to see a lot of ripple, a lot of load or anything really, so yeah, it's not like they need to be super low ESR or anything particularly amazing. So I think these will work fine. The ripple current rating is actually slightly worse on these Panasonics than on the Capexon, but again I think the circuit is such low power it's not going to matter. Now this one is slightly taller than the one that's in there, a couple of millimeters, but there's enough room in the case. This is a 20mm cap I think, and this is like 18 or 16 or something. That should still fit though, because I've measured the distance between the front panel down here where the cap is. It's right next to the binding posts, and the distance up to the side of this nut, which is where the PCB lies on, and yeah, it's like 22mm or something, so there's definitely enough space to put a taller cap there, so that's fine. This might be a little tricky for this cap here, because we got this resistor like connected across the pins and stuff, so that'll probably fall off when I go to desolder that, but you know, it's easy to put back again afterwards. Alright, I got that one out. I already broke the glue, so it just popped off very easily. But yeah, that, oh no, it's C236. I don't know. That's probably a date code, but I don't know how to read it. I thought it was 02, but yeah, no idea what date that is. So I just heated these joints up and just pulled the capacitor out. I might be able to do that with the other one and push it in. So of course, bend the leads like the previous one was, and then the longer lead there, that's the positive. So if I just heat this up and just push it through, there we go. It's actually free too, so now I just got to get the other one in, get the other one pushing up into the other hole, and then heat that. Get that through. Alright, they're both in, and then I just got to wiggle it through. There we go, that's nicely in there. Much easier than trying to do it the other way. Of course these joints aren't perfect. What I'll do is I'll cut the leads off, and then I'll just reflow with some fresh solder just to make sure the connection is good. There we go. And yeah, let's solder that on properly. Excellent. And there we go. So that's all good. Sorry, my camera is being useless. I'm not really focusing on this. Now I can do this one. I might just do the pull it out and rocket method. There we go. That one's come out. Might be able to do the same thing here actually. This is just doing it the lazy way. But I mean, yeah, it works. I'm just going to make sure that's flush on the board because we don't have a huge amount of space. So what I usually do in that sort of situation is I solder one of the leads and then I push down on the cap. You hear that little click as it sort of went into place. So now it'll be flush against the board. Yeah. And then we can solder the other leg. So now we just got to do this 220, which is hot glued down. So I guess I'll do the alcohol trick. Put a tiny bit there, and that'll soften up the glue. It does make it a bit sticky and stuff, but it should work. There we go. Mop up that residue, and then I can just do the same thing with this. Heat it and pull it out. That wire is probably going to have to come off, and this one's being really annoying because it wants to get in the way and get melted. Oh, I see the problem. I was desoldering the wrong point. No wonder it wasn't working. Now it makes sense. There we go, managed to get it out. The leads are all twisted to heck, but it doesn't matter because we're replacing it anyway. Alright, I just had to take this wire off because I was melting it and I put some heat shrink on it to go over the melted bit. Now I've just got to solder this back on. Wonderful! So now that looks all good. So we've got the brand new caps there. And now we just need a new potentiometer, I suppose, which is unfortunately not the one I wanted to use, but that's the only one I've got. Maybe I should do a quick sanity test just to make sure it's actually correct. Let's grab this little thing here that I fixed in the other video. Why not anyway? Let's just test to make sure this thing makes sense. Yeah, 52k. And the wiper is 0. Okay, we're at the bottom end there. No, that's the other way. Okay, we get 52 ohms at the top. 52k ohms, sorry, and we turn it down. It goes down all the way to 0 ohms, as you'd expect, and then we gradually turn it up and it looks like it's working normally. So yeah, that's good. We can put that one in. Definitely looks in better condition than the old one. So let's install this. So that does fit in there pretty well. That is definitely the right size, although it's not the right shaft type, fortunately, but whatever. I'm not going to put much solder on this because I don't expect to leave it in there. I probably will eventually replace it with the other one. Now I've just got to shove this back in the front panel. Okay, so I know you can't really see it because of these wires here, but I'm going to bolt the binding posts on first because these are the kind of things that will secure it. And for example, the solder joints for the meters that we have to put back on, we don't want to solder those first and then bolt this down, and the board will probably move a little bit, so and could break the meters or something. So for all that kind of thing, you definitely want to put any screws and stuff in first and then solder the meters in last to make sure that you don't have any issue like that, you know. Make sure everything's mechanically robust and then not going to move before you solder stuff in, otherwise you risk breaking stuff if you screw it down afterwards. The speaker terminal jacks, the ones for the low current output, I'm going to screw those down first, and then I'm going to bolt down these binding post nuts. These definitely have to be nice and tight because they carry a high current, and that's good. So that's all down there. and then I can tack the meters in. And again, I won't put much solder on these because I'll have to take these out again anyway when I replace that pot with a better quality one. And of course we don't need more than that because the solder joints there provide no mechanical support. It's irrelevant for that, so we don't have to worry about it in terms of that. Now I haven't hot glued these caps in because honestly I don't see there's any point. This thing's not going to be vibrated or anything much, so it's not a big deal. And you can just test fit this knob. I should have done this before, but I'm pretty sure it's fine. Yep, that works. It's good enough. Looks a bit silly, but it works. And then I just got to screw this thing back together. Oh yeah, I'm going to put the new fan in. So I decided to go with the new one. I tested them together, and this one is a bit louder, but it's also got more airflow and it's faster. So yeah, I think this is better for cooling, considering with this thing, when I'm using it, I probably will be dissipating quite a bit of power in the heatsink, so I think having the faster fan with the higher airflow is actually better, even if it's slightly louder, but the noise is not too bad. It's kind of a nice soft whooshing noise. It's not like a rattle or a buzz or kind of a humming sort of noise, so it's not an offensive noise. There are some fans that have a really, horrible kind of sound to them even when they're brand new, and this one doesn't. It's quite pleasant. So yeah, it's a bit louder, but it's better, so I'll use it. So one trick I found with these kind of fans is before you mount them in the case is to actually sort of tap the screw holes first. So get your case screws, fan screws, whatever. These are these weird ones with the really sort of coarse thread, and just put them in the fan while it's on the table. It's a lot easier. This one's actually really soft, so maybe I didn't need to do this, but I find it much easier to sort of pre-cut the threads like this first than when you're trying to mount it in the case or whatever, because yeah, it's a lot harder. Some of these fans have very stiff plastic. This one's actually really easy, but some of them are very difficult to do, and it's quite a pain to try and do it while you're actually attaching it to the device or the computer or whatever. So I definitely recommend tapping the holes first with a screw before you actually put it in there. It often saves a lot of annoyance. Anyway, now I'm going to put this in. I'm going to have the label up this way, the way it should be read, so that it looks nicer. We just need to sit that in there and put the fan grill over the back. Just hold it all in place, and it just goes in. And of course the other trick is when you put the first screw in, don't tie it up tight, because it won't work very well. So while everything is nice and loose, you can add the other ones in. Goes with pretty much everything, really. The holes on this fan grill are actually a little smaller than the screws, so it's kind of a little bit of a tight fit to actually get them in. But there we go. It does work. I just need to solder that fan in, and then we're done. And that's pretty simple. It just solders down there on that little board. The black wire goes here, and the red wire goes there. And I will actually modify this fan circuit, fan control circuit, to some point, so I have this fan running maybe at half speed like normally, and then it goes to full speed when the cutout kicks in on the heatsink. That would probably be a good idea. I'm just going to figure out how to do that. I'm not going to do that right now. So we've got this thing coming off the main rail, which is either going to be about 15 volts or 30 volts. Then you've got this Darlington transistor BD881 or 681 maybe. Can't really read it. I'm sure you could read the part number off the actual transistor, but I haven't done that. Then you've got a fan, so this just switches on. So normally this is I think pulled low with this cutout, which is a normally closed contact. So the base of this will be normally pulled to ground, and so the transistor will be off. When this cutout opens, then this is pulled up to the main rail by this resistor here, which looks like it's 6.8K, I think, 40, if I can read that correctly. And And then yeah, but it'll be clamped by this diode, which looks like a 13 volt Zener. So that's what keeps the fan voltage correct. So we've got a 13 volt Zener plus like the voltage drop on the transistor equals about 12 volts of the fan, so that makes sense. But either way, I won't do that right now, so I'm just going to have this thing working just standard, but just with the new fan and the new caps and the new potentiometer, so we can at least just test it out and make sure that that voltage control is actually working properly now. Alright, so I've got the thing back together. Well, not fully back together, the case is normal, that doesn't matter. I've just got to test it out and see if this control actually works properly this time. So if we just switch it on, alright, we get nothing here because these are all down the low end, so turn the current up a little bit, and if we adjust the voltage knob, look carefully at the needle there and see if it works properly, and you can see, yeah, it adjusts nice and smoothly on the low end, which is what it should do. If we turn it up to about 15 volts, you should hear the relay click. Yep, and then we can go all the way up to 30 something volts. So yeah, that appears to be working just fine. We can go back down again, hear the relay click off, and we can go all the way down to the low end voltage, and it doesn't do anything weird. So that's wonderful. So yeah, so it looks like that problem is fixed now. Alright, let's just see how easy it is to adjust this down to a low voltage. We turn this up, we get a few millivolts. So yeah, I mean, you can set this to a pretty low voltage. 150 millivolts, 400, 800. Get to like 1 volt there. Like 2 volts. Yeah, it's okay. About 3. I mean, this meter's not super accurate as we saw before, but yeah, it's much easier to adjust this now as well, actually. So that's actually not too bad. Maybe a 1-tone pot is fine for this. You just have to touch it really carefully. And obviously have a digital meter to actually check it, because these aren't very accurate. Or at least not very good resolution. It's hard to tell exactly what voltage you're at. So yeah, but otherwise it's not too bad. But yeah, this clearly is working much better in terms of adjustment than the other one was. We can actually set it to a very low voltage if we want, and it doesn't spike up to 15 volts. We can even go below 1 volt. You know, here we go, half a volt, and it's well, there's no load on it obviously, but you know, we can actually adjust it down to like really small voltages, and it does actually stay there and doesn't go crazy. Alright, so let's see if we can open this potentiometer up and have a look inside and see if we can see any obvious damage or anything. Maybe sort of lever those up. Yeah, that works. You can sometimes get pots apart like this and clean them if they're thing, but usually they're worn. That's usually the main problem with this. So anyway, the bottom is coming off. Yep. Okay, the wiper looks fine, I think. I think it's clean. It's got 3 contacts, which is interesting. All in parallel. I suppose that's for reliability, although this thing isn't being very reliable right now. There is a little bit of residue on the wiper there, but the contacts actually look fine, so I don't know. They look clean anyway, but they might be worn, so I'm not sure. But the other side here, the actual track part, it's really hard to tell. There is a kind of a line, but that looks like the same on both sides, so that might be part of the manufacturing. It's interesting. Looking at it up close with this, I can see where it looks maybe a little bit pitted down that bottom end, so it could just be dirty and worn. I can try to get a close-up with my other camera. I've got this little Sony camera here, which I can fit this loop over, and it actually gives me a very good zoom in. So let me see what I can see with this. So yeah, it's really hard to tell if there's anything bad about this, because it honestly looks like quite good, but on this end here, it looks a bit scored and worn, possibly. which is the area that was giving trouble. And there is this sort of diagonal line across that bit in the middle, where the centre of the wiper goes, which could also be an issue. I don't know, in this diagonal line here, there seems to be manufacturing. So yeah, so I don't know, like the top end there does look cleaner than this end. This one kind of looks a bit more dirty, but I mean, there's nothing like super obvious about it. So I don't know. Yeah, maybe cleaning it would help, but I think it's just better to replace it, because you never know how reliable the cleaned one is going to be. It's still going to have wear on it. I think, you know, being in a university, this thing probably did have a lot of use in a lab, so it's probably most likely just worn out. The wiper looks fairly clean. There is some residue there on the 3 points, but yeah, I don't know. Hard to say. Is that normal wear, or is that, you know, excessive wear? I don't know. I haven't opened many of these up to compare them, so you know. The inner contacts don't seem very dirty, but these three on the outer side do have some kind of residue there. So yeah, interesting indeed. So yeah, there we go. I kind of expected to see maybe a very obviously burnt part down here or something, but apparently not. I think this thing is just worn. It probably has had a lot of use and it's just worn out. And I guess, yeah, people have been using it on low voltage, so that's where it's worn out. That's probably where the most you know, movement has been, and eventually, you know, you've got one surface rubbing against another, and eventually it just wears away. I don't know. I mean, this thing could well be 15 years old, and it could have had, you know, many years of use on it. So, you know, maybe this thing has actually lived its lifetime as much as it was spec'd for, and it's actually fine, and now it's just gone, and we need to replace it, and we have. So, yeah, there we go. Not much more I can say about that. I guess there's no catastrophic failure of it or anything that I can tell. It actually looks pretty nice. So there we go, the Dixmuth Q-1760, pretty much fixed now. You can turn it back on again. And maybe I'll do a little bit of a load test just to see what we get out of it. Alright, let's give it some kind of load test. Got my tester on here. So this voltage here, 0.85, is actually pretty close to what this is showing, 0.89. So yeah, I mean, this is close enough for like basic testing. Let's maybe give it like 1 volt. Let's see. We can set it to about 1 volt. Yeah, we've got 1.04 here, we've got 1.08 there basically. This meter is a little bit out. I think the voltage is actually lower. Alright, so let's turn the current up. We're doing 1 amp at 1 volt. I mean, that's rock solid, still 1.04. This has dropped down a bit because we've got the resistance of the leads. Obviously, I'm measuring right at the output terminals, so you'd expect that to be solid. You know, that's right where the output is. Obviously, a higher quality power supply would have separate sense terminals, so you can, you know, connect separate sense wires directly at the load, and that will let you measure the voltage at the load, and then the feedback circuit in the power supply can actually compensate for what's delivered to the load, and it will negate the effect of the voltage drop on the cables and all that sort of thing. But yeah, I mean, it's going. It's barely even getting warm actually, because these things should be getting about 15 volts in at 1 amp. They should be dropping well, about 15 watts I think. So I'm kind of surprised that this is as cool as it is, but I can feel a little bit of warmth there. But yeah, but just basic power supplies like this, the feedback is only at the terminals basically, so anything on wires at the end, you know, that will drop voltage because of the resistance of the wires, and these aren't very good leads. I'd have to build some more that are a bit better. I'm going to do that. I'm just getting some terminals to bolt on properly, but yeah, so you can definitely see it works. It's stable under load. I mean, this is only 1 amp. We can turn it up a bit more, I guess. Can we? No, I can only get 1.2 amps out of it before the current limit hits in, which makes sense. You can actually see the voltage drop slightly. And as we try to draw more current, the voltage keeps dropping more. We can only draw about 1.2 amps out of this at what the current limit is set to. So yeah, if I turn the current limit up a bit, see if we can pull some more out of it. My load is not designed for super low voltages, so probably not going to be able to pull much, actually. Got like 1.5 amps. It's getting a bit warm now, but yeah, I can basically turn this all the way up. It only works at like voltages that are about 3-5 volts or something. So yeah, that's not really not a very useful load for low voltages. It has dropped slightly, and that's probably because the control circuit is heating up a little bit and component values are slightly changing. So you're going to see like a little bit of a drift that way. That's why it's good to set stuff like this once the thing is actually warmed up. Heatsink is warm, not untouchable, but yeah, I don't want to run it too hard, especially with the case off, because if it gets hot enough for the fan to kick in, there won't be proper airflow to actually cool anything down. So we don't really want to do that. But yeah, it seems okay. It seems stable. It seems to be working fine. You can set it to a low voltage, you can draw current, it works, it regulates, yeah, everything's pretty good. So we've fixed that problem there, I'd be very concerned, if I tried to do that with the old pot in there, that it wouldn't just fly around to some high voltage and cause a problem. So I think that's fixed. We have that new thing. I mean, I can use it with this other knob, I guess. It just looks a bit odd, but it's perfectly usable. And this knob actually fits pretty well. So yeah, I'll just use this potentiometer for a while and maybe get a better one later. But yeah, it'll be interesting to see how long this lasts. These are quite cheap. AliExpress. It's about what was it, $3 US or something for 5 of them. So pretty cheap, considering that was about a price for one from Mouser. But that's what I mean. You get what you pay for. Who knows how long this will last, and who knows how much wear and life this one had on it. It's falling apart again. Yeah, I mean this one here could have been, could have had like 15 years of hard use on it, and it's actually lasted really well. I mean, all these things have a finite lifespan, obviously, especially something mechanical like this. But yeah, I mean, this might last 15 years of heavy use. This might only last 1 year of heavy use. Who knows? And it's the difference between something quality and something cheap. So there we have it. The Dick Smith Q-1760. It appears to be fixed, and it appears to work pretty nicely. So yeah, we can definitely do that. Obviously we could do some more load testing on it and check the actual output with a scope and make sure that the ripple's all good. I might do that later, but I think this video's gone on long enough. And also maybe revisit the fan circuitry. Maybe change that so that it runs at low speed normally and then kicks into high speed, full speed when this gets hot enough. I think that might be a smart idea. These are still not very warm, so yeah, but that was only, a couple of minutes of loading it up, so I think, yeah, I wonder what those resistors are like. Yeah, not very hot. Yeah, transformer's still totally cold. Yeah, because definitely, if you're running this for longer than a few minutes, you definitely want that fan going. But yes, it does seem to work. And sorry for the squeak. But yeah, I've just got to put the case back on, and then I can use it for things. So that's nice. So yeah, that's that for this one. Like I said, it's fixed. It works now. The adjustment is actually usable, and it looks all good to go. So all I have to do is just put it back together, put the case back on basically, and that's it. And oh yeah, as a bonus for removing the fan rivets, I got 4 spare washers out of it. They were used to hold the rivets in. So there we go. Hopefully that was interesting. Hopefully that was useful, and I'll see you next time.